Welcome to another Ziva Math video. In this video, we're going to practice simplifying exponents. Let's take a look at the laws of exponents before we get started. The product of powers rule says that when you're multiplying expressions with the same base, you keep the base and you add the exponents. So if you have a to the m times a to the n, that's going to equal a to the m plus n power. The quotient of powers rule says that when you're dividing expressions with the same base, you subtract the exponent in the denominator from the exponent in the numerator. So if you have a to the m power over a to the n power, that is equal to a to the power of m minus n. The power of a power rule says that when a base raised to a power is raised to another power, for example, a to the m raised to the n power, you keep the base and you multiply the two exponents. So we keep the base a and we multiply the exponents m times n. When you have negative exponents, for example, a base a with a negative exponent, you take the reciprocal of the base and you multiply it by itself n times. So a to the negative n, the reciprocal of our base a is 1 over a, and we'll multiply that by itself n times. Any number raised to the power of 0 is equal to 1. This includes variables raised to the 0 power as well. A to the 0 power is equal to 1. Now let's look at how to use these rules when simplifying exponents. Here we have x to the 8th over x to the 3rd power. We're dividing expressions with the same base, so to simplify, we will use the quotient of powers rule, which says that we will subtract the exponents. We'll be keeping the base x the same, and we'll need to subtract the exponents. We'll take the exponent in the numerator, 8, and from it, we'll subtract the exponent in the denominator, the 3. 8 minus 3 is 5, which will be our new exponent. So this expression simplifies to x to the 5th power. Here we have y to the 6th power over y to the 10th power. We're dividing expressions with the same base, so to simplify, we will use the quotient of powers rule, which says that we keep the base y the same and we'll need to subtract the exponents. We'll take the exponent in the numerator, 6, and from it, we'll subtract the exponent in the denominator, the 10. 6 minus 10 is negative 4, so we have y to the negative 4th power, a negative exponent. We'll now need to apply the rule for negative exponents, which says that we need to take the reciprocal of the base. The reciprocal of y is 1 over y, and our exponent will be 4. This expression simplifies to 1 over y to the 4th power. With 5 to the 4th power times 5 to the 3rd power, we're going to apply the product of powers rule because we're multiplying expressions with the same base. This rule says that we keep the base, in this example the 5, and we add the exponents 4 plus 3. 4 plus 3 equals 7, so this expression simplifies to 5 to the 7th power. 5 to the 7th power is equal to 78,125. For b squared raised to the 6th power, we will apply the power of a power rule. This rule says that we keep the base, in this example the b, and multiply the exponents, 2 times 6. 2 times 6 is 12, so this expression simplifies to b to the 12th power. For x squared raised to the 0 power, we will apply the power of a power rule. This rule says that we keep the base, in this example the x, and multiply the exponents, 2 times 0. 2 times 0 is 0, so we have x to the 0 power. Remember, anything raised to the 0 power is equal to 1, so x to the 0 power is equal to 1. You could also have thought about this example as simply being x squared raised to the 0 power. Again, anything raised to the 0 power is 1. In this example, we have x to the 4th power times x to the 3rd power. Because we have the same bases, we can apply the product of powers rule. We will keep the base x and we'll add the exponents 4 plus 3. 4 plus 3 is 7, so this expression simplifies to x to the 7th power. Thank you for watching. Be sure to like this video and subscribe to Ziva Math for more videos.